Let me introduce Sarah Rudder. She's from Enola Tech. She's going to be talking to us about ontologies. This is some of her research work she's been doing for her graduate program, her PhD. So we're all excited to see what you've got to talk about, Sarah.
All right, thank you very much. All right, thank you guys for attending. As Dr. Dan mentioned, I'll be talking about ontologies, specifically how LML was created, and then kind of comparing it. I do not have one.
Yeah, you should. Yeah. Let's see. Testing 1, 2, 3. Testing. There you go.
Okay. All right, is that? Nope. Okay, I'll just hold it. Okay, so can you hear me now? All right, so I'll be talking about ontologies and using LML as a case study. So I'm going to briefly go over some of the concepts. A lot of times when I talk about the O word, people's eyes like glaze over, but I do want to give a brief introduction. I'll be talking about my research approach, the results, some discussion, and then the main takeaway here, there are actually two. I want everyone to kind of understand the importance of ontologies for actually building these modeling languages that we, are familiar with. Okay, so MBSE, so we've, you're here, you probably know we've been moving from a document-based approach to a digital environment. A lot of times we hear about the 3 pillars of successful MBSE as the method, the language, and the tool. So fairly recently, within the last 5 years, Cohen and Dory have argued that MBSE additionally requires an ontology. So if we look at this graphic here, I'll only be talking about the language and the ontology. I am tool agnostic, so just want to point that out. All right, so just a brief overview of the language. So LML, and I just heard that we're now on version 2, but this research was done, a month or 2 ago. And so LML is an open standard modeling language that supports the full product lifecycle and integrates with other project disciplines. So it's focused on a very limited amount of views that represent our functional, our physical, and our traceability system aspects. Some benefits of LML compared to other graphical modeling languages: it's easy to understand, to extend, it supports functional and object-oriented approaches, it's useful for stakeholders across the entire system lifecycle, and it supports all project lifecycle stages, starting with our requirements. So again, these are some benefits, but I'm going to focus on the language here. All right, so for ontologies, is anyone familiar with ontologies? A little bit. Well, okay, we've got a few. Yes, thank you. I know a few of you are, but so in general, we're talking about a specification that describes a common language by set of representational terms. So the point of this is to constrain possible interpretations of the language, so the intent is so that we can communicate more clearly. And I'll be talking about domain-specific ontologies, which is obviously systems engineering at this point. All right, so the other main point of this is to see why they're important, but then also see how during this presentation, there are a lot of terms that have, synonyms that I will go through, but that really confuse language even more. So really, yeah, you'll see that as we go. Okay, so to accurately exchange information, we have entities. So you can kind of think of those as classes, and then associated relationships between entities. All right, and those must be explicitly defined, which is incredibly difficult when you're thinking about, well, anything. I'll use this as an example. I would refer to this as a graphic. Some people may refer to it as a picture. I have a colleague that we often get on the wrong page with each other. Because he'll say diagram, and when I think of a diagram, I'm thinking of like a SysML diagram, for instance. So even just this one representation can be called many different things. But the point of this representation is to show we also have edges, which are those relationships, and nodes, which are those entities. So again, a lot of terminology to talk about the same thing. And just a very brief example, if you are familiar with the LML specification v1.4 at the time of this, there's this matrix here that shows the entities and the relationships between them. So just looking at this characteristic row, the way this is read is that a characteristic specifies there's other relationship, an action, and a characteristic specifies an artifact. Okay, so very clear. These are also called triples. Okay, so another term there. Then there are inverse triples, so action is specified by a characteristic, etc. Okay, so a few benefits of an ontology. So this is actually a graphic from Protege, which is the ontology editor that I use. It's the interface between knowledge representation and reality. The intent, again, it depends on how good your ontology is to create a common understanding to enable that reuse of domain knowledge, define the assumptions. So that's super important, defining those assumptions. And then we've heard already a little bit about the ability to analyze this knowledge. This is just another representation of, you can see our nodes, and this is from the actual LML ontology file that Dr. Dan provided me for v1.1. And then you can see the edges. So these can get quite confusing, but there are tools like querying and things like that that I won't get into today to help with that analysis. Okay, and I don't want to get too far in the weeds, but just a few more things about ontologies. They give, there are several languages in how we create ontologies. So BFO is a big one, basic form ontology. This is how I think V2 is being created. We have occurrence and continuance. So basically continuance are like entities and occurrence are like processes. So some even more terms there. This is from the LML spec. Examples of a process would be like an action. And then continuance, so those entities, examples would be like an asset, a conduit, or a resource. Okay, again, a lot of this is to show you how convoluted this can be. There's also OWL, so the web ontology language. This allows an iterative approach. So I don't remember the exact article, but I read somewhere that a complete systems engineering ontology would take something like 50 years for a human to create. Nobody has that kind of time. That is where AI comes in. What do I want to say here? RDF, this is what OWL and BFO are based on. It's a common approach for expressing information. The important point here is that RDF is how we have a language that is also now machine interpretable, in addition to understood by humans. So we have subjects and objects now represented as nodes or vertices, and predicates or those triples shown as paths or edges. All right, and this is my last slide with a lot of confusing language, and then I'll talk about the conclusions briefly. All right, so RDF defines all data as triples, so that subject, predicate, object, also the entity, relationship, entity, node, vertice, vertex, node, a lot of ways to say the same thing. These represent what are called facts or axioms. And so those are statements that are true of relationships within a language. All right. And this is just so LML v1, there are 20 entities, core entities, and that is a lot more manageable than some other modeling languages out there. But these also need to be explicitly defined within the tool, and then you're able to extract those triples from the definitions and from that matrix, from those relationships within the spec. So This is from the initial ontology that was provided, I think maybe like 2017 was when it was created. So there are 20 entities. There are 87 object properties, which were those relationships, and then axioms, so that those statements that are facts. Okay, so like I said, this will take a person like 50 years to do. So I've started writing code to get this done for me. Actually, that's not true. ChatGPT is writing code for me to get this to work because I don't code. So it's taking me a little while to get it refined because I just keep copying and pasting and asking it to fix the errors. But so from this very first, so this is already 1,000 axioms. That does seem like quite a bit until we get to, well, this is my very first iteration of the code, so please don't judge these numbers. You can see when I ran it. So I ran the whole spec and I was looking for all nouns and all verbs. So the numbers are much higher than 20. And same with the verbs. So I ran the entire spec as a text file. And this was before I had my RDF extractor running yet. So I estimated that we would have 14,000 axioms. So exponentially increase as we see those classes and object properties go up. So that might seem like a lot. But when I ran the RDF extractor for the first time, again, I don't code, so this is a progression. This is very crude to begin with, but it gets better, I promise. Had the first viable iteration had 115,000 triples, so those RDF triples. That's, you know, an order of magnitude more. So I am currently refining this, and I had to turn this presentation in before I got the final numbers, but I did compare this to SysML-v1. And okay, well, first off, so I've gone through several more iterations of the RDF extractor code, the one I ran last night, so obviously most recently. Has 1,400 axioms, so much closer to that 1,011 axioms, so I'm getting there. When I originally ran this, so the first one that came up with 115,000, and so 230,000 in total. When I first ran that against the SysML spec, I got 22 million. So you can see how this exponentially increases and how having that underlying ontology with explicit definitions and how entities relate to other entities can be very, you know, important and helpful as we're learning and communicating across disciplines. I did get that down, the newest version of my Python code, to 2 million. But that's pretty much the conclusion, is that these ontologies can be really helpful when building graphical modeling languages that help everybody. I think that's all I had. So thank you for your time. Are there any questions?
Anybody have any questions? So let's go ahead.
Yep.
So you see this progressing for like further banks data model grow?
Yeah, so this is part of my dissertation. I could talk about that forever. I'll try not to. But I'm using this as part of an ISO 15288 ontology and seeing how these languages map there. Yeah. Yes.
I know you said you're tool agnostic, but do you have an idea of how this ontology would be implemented in either Enola or Quintero or a modeling tool?
So I didn't talk about it a ton, and I haven't gotten that far. There are these there are tools out there like that are OWL editors, and as far as I know at this point, Cameo is the only MBSE tool that will import an OWL file or a BFO file. So at this point, I think that's really the best option. It'll also export that way. And it's called a concept model, Cameo concept modeling, but that would be the way to do that at this point.
you used any syntax converters?
Just like.
Oh, sorry.
Gotta have the cube.
Oh. Have you used any, syntax converters for now?
No, I have not. Turtle is the other one I'm looking at because I can get my Python code to give me a turtle file, the terse RDF language. But no, I haven't tried converting them really at this point.
Yeah, it'd be interesting, with all the importer, features to the tools across Cameo or something else.
Mhm.
There's a way to normalize syntax because, Cameo is gonna do proprietary things. So once it gets in there,
Mhm.
then you'll be stuck.
Yep.
And Genesis.
Yeah, it's been interesting, because some of these I've actually created in Cameo with the concept modeling or concept model and then, converted the other way. And it's just, it's been interesting. There's a lot more than, just this. But yeah, obviously it's my work. I think it's interesting.
When do you anticipate, right?
Few months.
Oh, awesome.
Yes,
Okay.
I'm close. Thank you very much. I'm ready to be done. I know too much about ontologies at this point.
Scott, go ahead.
Oh. Okay,
No idea.
basically, I was curious about the attributes. Each class has a set of attributes, default attributes, added attributes. I might have probably missed it. How are those incorporated within?
Okay, so I didn't get into that here because I really didn't want to bore everyone to death with
Yeah.
ontologies. But attributes are captured either as they're called data properties and an OWL editor.
Okay.
That's the short answer.
So does that capture both on the class and also on the relationship? I couldn't find that now when I tried to do the original file.
So, sorry, can you repeat that? The classes.
So we have attributes on relationships as well as on the
Right.
class.
So, without having protege, I think you can get the data properties onto object properties, but I would have to open up the tool.
I didn't find any way to do it, so that's why I
But
didn't.
yeah, I mean, there are updates all the time.
Yeah.
I can check, but that would be good to know.
Because a lot of the trouble we have is attributes are a big hurdle as well.
Mhm.
Connectivity and it working together is one thing, but then the availability across platforms is the other. And it makes, you say 2 million for a tool like, a language like SysML, even ours, LML. And that it makes it very complex, even more than 2 million
Yeah.
or 115,000. When we get into the attributes.
Yeah, so at this point, this is only the verbs
Right.
and the
Okay.
nouns.
Gotcha.
Cause you're right. My computer already crashes all the time with
I
this,
guess.
so.
Thank you.
But we'll get there, so.
And that's why we also did typing as part of that, so we could minimize the number of classes we need. So because they're basically the same fundamental type of thing. Any other questions?
Yeah.
She's on one.
That's okay, it's the industry.
When you said that you ran the SysML standard through, is that just basically taking the standard from Encosi or OMG or whatever, and then seeing what nouns and verbs exist in it, or was there something else to it?
Nope, at this point, well, that's not true. So again, my code input got a little bit better. It was looking at those triples, so characteristics specifies artifact. So specifically looking for those, but I think the way the code is right now is looking at also, well, actually when it was 2 million, not now that it's a little better. It was looking at inferred triples instead of just, what's written. And I think that's why it got so blown up, but I haven't confirmed that in the last few weeks.
Okay, I was wondering if the difference in the numbering was because it's more inconsistent, like there might be multiple ways that it refers to the same relationship.
I think that's part of it. I haven't gotten that far into the analysis. I think the numbers alone are kind of scary. So, but yeah, I think that's definitely part of it. The more ways that you refer to picture, I mean, the more confusing it gets.
It's important. People online can't hear the
I
question.
understand. Okay. Sarah, over the years, I've heard the term, we have to have, or the expression, we have to have a tolerance. After our discussion this morning on AI, I'll even here see a future where AI might start creating common ontologies for enterprise.
I would hope so, because, I mean, I couldn't have even written a Python code to do this, without, well, Claude is what I use now, but, yeah, I think, being able to have a machine interpretable, those triples, can be incredibly valuable. There's also what's called within like an ontology editor, the equivalent class relationship, so that you can go in and see, oh, hey, a graphic is the same class as a picture, the same class as a diagram. So there's a lot more that I think you can do, and definitely AI would help with that.
More questions?
Thank you. I'm loving all the questions.
Just fully recognizing and sympathizing that you're not like an expert coder. I mean,
Nope.
I feel like no one here is. What runtimes are you looking at when you're using this system? And is it something that, I mean, I assume you're familiar with like big O notation. Basically, how does it scale with the amount of input data, and how long would this take? Something that can be done in a few seconds?
Yeah, it's still only taking a few seconds, whether it's 500 or I think the 22 million one took like a minute, but still it's not anything significant. It just crashes sometimes. And that's probably my computer, so.
Thank you so
All right,
much.
yeah, thank you for all the questions. Really usually,
Applause, please.
yeah.
And so we have a 5-minute break between papers, so we can set up for the next paper, and also so you can, if you do want to go to another room, you can do that. So that's why we're doing the times the way they are. So, okay. So. Okay, you're up next.
Going right after the keynote speaker, but I'd like it now. And I get it the first time. That was good. What are you talking about?
First one is basically overview of Oliver.
Oh.
Second one is data.
So you get to see yourself too.
Yeah, I think I uploaded it on Monday, another version. Is there any chance?
Well, if you,
Too late?
it's whatever I downloaded last night.
Okay,
So if you did it
If
if you did it before then, you're good.
All right, thank you.
Right. I literally did.
Yeah, I know other people did it. It's like Sunday.
My credits are right here. So here. You can either hold it, or if you can clip it someplace. Test it.
It's an alternative.
Are you still involved with Jordan?
Oh, not very much so. In fact, I think their Andy Sage conference is tomorrow. It's like, oh, I'm just saying, I'm missing it. Yeah, we said
How many?
I wrote that down.
It is. If you have.
So it was something close on before it was the Andy Sage.
Correct, yeah.
They were using
He was a
many years.
professor before my time.
Yeah, he was amazing guy.
That's what I was doing.
Yeah.
I had, Lance share, as my capstone showed, checked on it.
Oh, okay.
And I think they're both still there, right?
No, actually, George is retired. Thanks, still pretty young, so he's still going hanging in there for a while.
I think, lastly.
Oh, yeah, Kathy Lance, she's retired, yeah.
Are you also a Mason grad?
Yeah, I graduated last year.
Oh, last year, okay. I am 21. Yeah. So a few years ago.
I'm 74. 1974, not 1874. Everybody thinks it's 18.
So when you were there, did they have model-based classrooms yet or?
Barely had an engineering class or two. So it was quite something.
Yeah.
It's changed a
I know
lot.
my first year we used 4, and then we switched to
So I thought, well, and they were like, just not impressed. They're just so good, I think, compared to, I mean, I was very excited about it, it wasn't, you know.
I mean,
I was like, I didn't have the AI, but I was super proud of it.
oh, the last 2 years, my master's and undergrad, I had a, without it, with a 5,000 horsepower. Took a lot, just took time.
I had to use internet, and then I thought, I'm not sure about this.
Yeah.
You know what, you're right.
It's ridiculous. Search engine.
Yeah.
Hey, this looks weird. That's all.
No, it's just like how much.
Yeah, so I did children, while I was at USN, but then I switched to
I'm
ManTech
getting better at
right
it.
after.
Well, no, in general.
Yeah, so at Dahlgren, I did research that.
Yeah, it's
No, I've been coached.
okay.
I think he was also amazing.
Yeah.
I don't think they're anymore. But yeah, I was in Hellcat. They both, yeah, that was a test.
FAI, they just taught models in, like,
That's cool, yeah, and then, yeah, the people that I know are still near,
still came.
hungry, with ages.
They didn't pump in models out. So.
But yeah,
Are you?
anytime, I know you just can't be older now. The fact that I always defend you.
So, I was
Just the fact that I knew that, you know, it's a
Yeah,
complex
01,
system, it used to be
03.
split, that's why I know.
They basically faked
It's tools in here.
So they have an agentic behavior where search the internet and things. See this conclusion and research. It goes out to back and forth.
Oh, I'm all, I like use.
It's a lot more.
And my
Yeah, a
question
lot
is always crispy. Well, because all the.
It basically generates proof
And
reads,
it's just
generates.
fine. The US is just so much better. So how come can't work for them? That's. Teacher. Yeah, the focus on other. Getting teacher.
Is that right? Yeah. It's getting better and better. Keep getting better.
That matters a lot. The users to the customers, you need them. Scary website.
Into time.
We released
About 20 minutes.
2 weeks later, the new model.
It might run short.
That's fine.
We practice and all that.
Yeah.
We're just not that.
You keep bumping.
She ready. I tend,
Yeah.
the adrenaline tends to get you going. So you gotta speak a little faster than other people, when you practice.
Right.
Okay, let's get restarted. Watch it.
What's the?
So our next speaker is Rebecca Quintero.
Yep.
Did I do that right? Okay, good. She's holds degrees in systems engineering from George Mason University and University of Virginia. She started a career at the Naval Surface Warfare Center Dahlgren Division, and is currently working for ManTech as a systems engineer. So, Rebecca.
All right, good afternoon. The mic's on. So yeah, today I'm gonna dive into AI-driven requirements management. I'm mostly gonna focus on the data part. So everything before you get it into the model and how I've been using it on a daily practice. So like Stephen just mentioned, my background's in systems engineering, specifically model-based systems engineering. I have 2 degrees in it. They were very different. George Mason does more of like the DoD acquisition approach, and then UVA was more like industrial, commercial innovation, but with systems engineering. I was at Dahlgren, that's where I did use InnoSlate, and then now at ManTech, we predominantly use Cameo.
We can fix that.
So yeah, just a disclaimer, because I get a lot of comments from either the customer or just people that are a little against AI, whether it's, you know, the climate consequences or the fear of it replacing people. But I think it only gives you a first draft. You have to validate it, so your expertise is critical. But it just accelerates work. It's really good at pattern recognition. It's good at classifying information, summarizing documents, and it really just speeds up time. for any kind of task that I'll go into in a little bit. So kind of the current challenge is all the manual processes. You'll receive a requirements document from the government. You'll have to read through it, manually extract the shall statements. You'll have to maybe even memorize them a bit when you try to map them to functions or other standardized libraries. But that's where I think that AI comes in handy. Predominantly, you need LLM models. They're great for parsing and extracting information. They're also good at quality analysis. So if there's a certain kind of draft requirement, you can ask it, how can I refine it? What gaps or inconsistencies does it have? It's also really good at semantic understandings, which comes in handy with traceability. So the way it works, and I'll go into it later, but it takes your requirements and converts them to embeddings and creates vector databases so that when you ask it to trace things across documents, it checks for semantics. Kind of like a door can be a hatch, things like that. It doesn't just check for keywords, but it checks for semantics. Another important thing that we need is better prompt engineering. That's where you can feed it certain, whether you say like criteria for requirements, the way you want it to be worded, you want it to be testifiable, verifiable, and that just helps with getting better responses. Another thing we need is multi-agent collaboration. So not just LLM models, but we need to create specific agents that specialize in either mission engineering, test engineering, requirements. And then we create it in a hierarchy so that the supervisor can route the tasks, and you just get better decision making. So here's an example of that. At ManTech, we've created multiple agent workflows specific for either the program. I support predominantly the long-range unmanned surface vessel for the Marine Corps, and they're currently in the phase where they're creating system requirements based on their capability requirements. So what I did was I created kind of like a bunch of agents. There's a supervisor that's like the main systems engineer. And when the task is received, he kind of like routes it. It's all autonomous decision making. But the most important part is that each agent has to have a persona. So you kind of give it the context of who they are, what's important to them, what kind of documents they might need to pull from in the document store, what kind of standardized library they need to refer to. You give it instructions. So you can say like my requirement needs a verification method. It needs to be verifiable, a bunch of, there's different methods for creating requirements. And then the last point is that the framework is a combination of LLM reasoning with other tools so that it can just decide based on what you type in the chat, what's the best function for it to use. So here are a few of my agents. For a few examples, the requirements engineer, like I mentioned, I fed it a bunch of information, and I'll show this in the next slide, but there's, in the tool Flowwise that we use, there's a document store where you can put a bunch of just standardized documents for them to refer to. So it has the NCOSI guide to writing requirements. It has example CDD requirements, ICD requirements. It knows that it has to create KPPs and KSAs. And then, like I said, you have to specify the output you want, just so that it kind of performs in a predictable way that you want. And I always ask, give me an ID, text, and then the associated capability requirement that it's decomposing, sometimes unit of measurement and threshold and objective values. I also have a systems architect agent who focuses on creating high-level functions. And that one, in the task description, I told it, try to allocate them to your functional requirements. So that's not just, not hallucinating, but in coming up with random functions, but it's based on the previous agent's work or a document that we have from the customer. And I guess lastly, Another example is the test agent. I had to give a description of what an analysis, a test, an inspection, and a demonstration is. And I like to tell them to rank it in which one's the best verification method and why. Just because sometimes it can be subjective. So here's an example of how I use it for requirements traceability. Being an unmanned surface vessel, there's not a lot of system requirement documents out there. So we do a lot of we try to collaborate with other Navy programs that are out there and see what requirements they have that we can either reuse or adopt. So this is all unclassified information. It's all fictional data, but showing the examples that I'm referring to right now. I fed it a bunch of different platforms, different programs, and asked it to summarize each one. So that's an example of just how the LLM can summarize information. And then using natural language processing, that's when you can give it just a direct instructions. And there I just told it extract all shall statements. But then the other example that AI can help us with is when it creates requirements to embeddings. That's when it doesn't look for just keywords, but it can match things. So it knows that there are different ways for situational awareness. It could be with a sensor or EOIR camera or a radar. So it's able to just find that relatability between different platforms and then map those requirements together for me. And in the end, it's a lot faster. This would have all been done manually. I probably would have done Control F to find things instead of using the AI. And then here's another example of using it for functional traceability. So here is where it's not just tracing requirements, but it's able to build a bridge between requirements and operational vocabulary. A lot of the time, I'm tasked to map my requirements to JCSFLs, MICTOLs, or just standardized functions that are out there in the DoD. So here's just an example of it mapping the requirements to the JCSFLs and MICTOLs. And then another example was operational activities. I asked it, each time you ask it, it might send it it's spitting out words based on statistics. So it sometimes gives me different answers. So I like to ask it, are there any additional ones? Like I like to iterate, don't just ask it one time. And I sometimes ask it to give me like the one that's the best related or the best recommended, and then additional and why. Just because it's really good at giving you rationale, and I feel like that's where our expertise comes in handy, because we still have to validate it. We can't just take it as a given. And then here's another example of a good use of AI. Say with RAG, you're able to put documents in a store and then ask the AI to build you something based off that document to recreate that data fidelity. So here's an example of, I fed it a mission engineering framework document that kind of just specifies what mission threads have to contain. And with the other requirements document in the store, I asked it to base those mission threads off those requirements. So it went, did all that for me, and even decomposed some system functions for me. But it's just an example that you might not have an example to base, you might not have like something to base it off, but it's able to check what's in the store and with the ManTech match your query to data that's in your store. Another example is if you want to create P-specs, you can feed it another program's P-spec and ask it to, when it recreates your system requirements, to base it off the data fidelity in that other document. And then here, it's just, I think something I've seen is that it doesn't replace subject matter experts, but I do think that it accelerates the work that could have been done with working groups or having to reach out to other teams. I can do a lot of like cross-functional tasks without having to meet with those people, or at least have something to show them instead of having to sit down and do the work all together. So in this example, what I did was we were trying to build a capability wheel with a mission engineer, and I was trying to figure out the gaps between have they, do all our capability requirements match to those, capability areas? And there were a lot of gaps. So I was able to run that through the AI and even ask the AI to recommend additional capability areas and a rationale for it. Which just saved a lot of time, and gave me a product that probably had more expertise than I could provide, and just helped the discussion. And then on this, I think is my last example, just the fact that with the agents, you can ask it to do complex engineering tasks. Here, I asked the test engineer to come up with a verification validation plan, which takes multiple steps. So the first step was coming up with verification methods for each of my requirements. And again, it ranked them, because sometimes, you could do an inspection or a demonstration, so it's good to know why I would prefer one or the other. And then for the verification test, for the test configuration, it was able to give me the configuration, the equipment I would need, and everything. So I just think it's just a good start, right? If you're on a program that doesn't have other existing platforms out there similar to it, the AI is just really handy for us, to just have draft information, and we don't have to just come up with everything from scratch. So yeah, that's it. The way forward, I would say again, is promoting agentic workflows, rather than LLMs, just because it helps with robust engineering tasks and with error handling. Again, with prompt engineering, it's iterative. A lot of those worker prompts that I came up with took weeks, sitting with the actual test engineer, showing him what the results were and how they could be better. Then we would go back and add that to the logic of the worker. And then the other is just, we need more risk-free software. Right now, we're in a controlled environment so that we could use CUI information. But if we want to, link to other tools, we need to make sure that they are safe for the government information. And then again, I think just the value proposition is the fact that it's made my work a lot more easier. I'm able to focus on just interpreting the information, validating it, and just providing so much more to the customer and a lot faster. That's all I have. Open to questions.
Okay, let's make sure we use the microphone here. Any questions? Oh, very good.
A lot of questions. Great presentation, utilities there. It's really amazing. We are thinking about deployments, and there's two real things. There's a lot of things. I mean, behind the firewall is one thing. Those things you can address to providers, but temperature. How do you adjust? How do you determine what temperature to be on to be as deterministic as you can be, but also stay, stochastic and probabilistic, because you have to be with stuff like this. Mm-hmm. It's not very, there's not always a correct answer to this requirement. You have to have some variability, but how do you control that? My second question would just be, was this obviously these were chatbots implementation? I'm assuming you guys have in-house products for each agents. But what model did you use?
Yeah.
For
I guess so. I'll answer the first question after. But so with Flowise, we have access to multiple models. I believe there is the Azure, then there's the AWS, Bedrock, and you can switch back and forth. Gemini, there's a bunch of them. Olama. But I've been majority just using the Azure LLM. And then we also have our own, it's called Mesa at ManTech, which that one's just an LLM. So a few of my examples were just using LLM. And then the latter was mostly just the agents using the Azure. But temperature wise, I think I usually try to put it high, like 0.7, just because I want it to be as precise as possible. When it comes to things like this, I don't want it to be too creative. I've realized that at least when I just use the LLM, because when we use the agents, it's constrained to the document store. So I ask it, don't look elsewhere, refer to this document that's there, With that one, we don't worry, I never see hallucinations, but with the LLM, I do a lot. So that's when I guess the first bringing up the temperature is really important. And asking it to specifically look at that document, don't make anything up.
Because once you give it the document or example of how, you know, another customer has done,
Mhm.
you know, their documentation, it pretty much just makes sure it writes like it. It does
Right.
like it or follows the exact rules if it doesn't, you know, so that control and that kind of testing, constant testing is kind of, we're trying to get the perfect, you know, a product. What's the perfect requirement product?
Mhm.
Is that something we should expect? That stuff. So that's what I was curious about was, you know,
Yeah.
requirements writing guy's really good, but how precisely it follows it, all that stuff.
Yeah, I think especially with the worker prompts, for each of them, I have to say, don't make anything up.
Yeah, you have to.
Because it wants to be creative.
Unless you put it at 0, it doesn't.
Right.
Then it's
Yeah.
not creative.
But yeah, they want to be creative. So especially when I do traceability, if it doesn't find a function in one of those libraries, it'll make it up.
Mhm.
So I have to ask it. If it's not in there, just tell me NA.
Thank you.
I feel there's probably no easy answer to this one, but I'm guessing you do some work on the classified side. Most of the work I do on the classified side, and I know a lot of people aren't. We have a in-house LLM on the class side that we put proprietary information into, but I don't think the government has access to AI agents like this on the classified network yet. Are you aware of any?
Correct. Yeah, so there's two I'm aware of. There's I believe it's called Cameo GPT, it's the Army one, and then Nipper GPT, it's an Air Force one. I played around a little with them, but I believe you can't attach files. That was the downfall I saw. And then the other one I think just knows like programmatic information. It doesn't look elsewhere. But yeah, same. We used, we're in a controlled environment for CUI only. And yeah, like I said earlier, the limitation there is that you can't link to other tools that are out there.
Gotcha. I guess the question kind of following up on what you're saying is, like, you have to give it documents to like replicate, like, hey, this is how we do it. I know speaking for my team, there's a lot of false start requirements when I use it. There's gaps and stuff. I would not want to take some of our current requirements and be like, hey, generate more of this, because we're not gonna be approving anything, right? I guess before you submit documents to the agents, you really go through and again, it's data driven, clean that thing up to make sure it's not perfect before you give those to the agents, or.
I think we probably should, but the fact that the requirements were signed and approved, we kind of take it as it was fine. But I think what we were doing right now with my engineers, that I produced a bunch of draft system requirements, but we still had to sit down and see how to tweak them. And then like 2 weeks ago, we were trying to add a few like requirement practices to the logic, telling it. I know there's one called SMART. There's another one where you kind of like try to phrase it in a certain kind of way. So we're trying to teach it ways to write requirements for when it does replicate it. Because like you said, the base document might not be the best. Yeah. But I think another advantage is that it's able to find gaps. Like for at least our system requirements, I list like I want a functional interface, safety, environmental, like it's able to just like cover all the bases and find gaps to decompose requirements.
Any question?
Hi, it looks like you put awful lot of work into this, so if I were a manager, I would probably say, how much of this effort take turns for the next, say, certain special? Is there a lot of this aside, just general knowledge and stuff? I think you can transfer agents, things like that, together to another brand new program.
Yeah, so so we had conflicting presentations, but my other coworker on the other side, he's like our AI lead, and he's briefing all the agents. But this is a requirements agent, so it's not just for my program. We're just trying to train it to know how to decompose requirements, identify functions, and come up with tests and verification validation plans. So it's supposed to be able to be applied at any program. All you have to do is just, submit any reference documents you need into the store. But it's, the whole point of the agent is for it to be, not specific to any specific program.
Cool, thank you. Anything else?
And since I guess you guys did miss this brief, we have C2 agents, DODAF agents, acquisition. Could you guys think of any other? There's a bunch. It's like 10 of them that they're developing. Yeah, can't think of all of them right now. But we're trying to kind of span not just the life cycle, but DoD acquisition.
Good luck.
You guys start with like a core set of capabilities, like what's your starting for development spec?
Like a new requirements document?
Yeah.
So I guess, so where I'm at right now, so we have a CD, a capability description document. But that's very high level, just capabilities. So I'm using that. I'm using another program's CDD and P spec to show the agent how those were decomposed as an example. And that's really about it. So, that's why we're trying to now focus on teaching it how to write requirements as well. And like I said, it's just a starting point. It gave us a bunch of draft requirements, but we still needed to sit down with the engineering team and have them review it. It's just a starting point.
So is there any plans to go any lower, and like that top level specification, go down to like a subsystem or functional area?
Yeah, definitely. Another effort that I've been doing is trying to map it to the Mill Standard 881. So the ship section there doesn't cover everything of our unmanned system. So I basically asked it to look at the whole Mill Standard and try to grab other subsystems from like the aircrafts or someone else so that I can create my own work breakdown. Because we are doing it, how the DoD and everything moves slow. Or we're creating a P spec now, but it's not going to get done anytime soon. Same as system design, or they're not going to have SRR, SFR anytime soon, but we're kind of working with what our customer needs, slowly by slowly. Any other questions?
Are you licensing any of your agents or your models?
I believe so. So we're using FlowWise.
I was flood contracts. Let us know how we did it.
Like I said, our AI team lead is in the other review right now, but I can follow up with that after.
Other questions? And I'm sorry, we haven't quite figured out how to get the questions from online yet. If it is, I may have any questions online. Let me just see if there's anything in the chat real quickly before we get to the next speaker here. I don't see anything in the chat, so yeah. If you do have questions, put them in the chat. I should probably mention that at the beginning. Most people would just do it. Okay. Well, thank you very much. Let's thank our speaker again. We'll get ready for the next speaker here in a minute.
Their IL5, Azure, like she mentioned, if you watch the government model, their IL5.
I know this stuff, I do the stuff that works. I'm not super close to it, but people on my team are AWS and Microsoft. But yeah, Azure, I guess.
I mean, if you build it in-house like they are, it's IO, whatever you want it to be, right? It's just in-house. But if you're trying to hit a cloud, then Azure has it, as Stage has it.
I think they just do something broken.
OpenAI has an enterprise, like pure pickup, you can apply for that as well. I don't know how to.
Ravi, can you unmute yourself? If not, let me know on the chat. Are you there? I think we got our first virtual presenter here, so. I don't know, is Ravi here? Amir, did you check in Ravi?
Ravi's up there.
Oh, what? He's online, but, oh, there he is, okay. You can unmute yourself. Can we hear you? He's online.
Hey, hi.
Yes,
Can you hear
there
me?
you go. That's better.
Yeah, so Brett is there.
I'm sorry?
Can you hear me?
That's
Brett, my teammate is there who will be presenting this presentation.
Oh, okay. Okay, great.
Can you announce the Brett name? Brett name is there. Brett is there in the presentation itself.
Okay, great.
Can
Okay.
you Brett name is there. Brett is there in the presentation itself.
Brett.
Okay. Okay, well, we'll have him, hopefully he'll be in here in a minute. Thanks. I'll go ahead and put up your slides then. For Hill House. Oh, yeah, okay, great. Okay, I knew, I hadn't made the connection. And this is a good reason why we wait to get people. So. Well, this has been some amazing presentations already this morning, so I must say. This has been some amazing presentations already this morning, so I must say. This has been some amazing presentations already. So Ravi, I'm going to have to mute myself, or you're going to have to mute yourself.
Once. Can you hear me? Brett, can you announce the name Brett Hillhouse? He's there in the event itself.
Yes, we're finding him.
Okay. He said he was there in the room itself, so I'm expecting him to be there.
Maybe in the wrong room.
Mm.
We have two rooms going, so.
The other person is still on. What's the room name? Can you tell me the room name? I will tell the
We're in
guy.
room one. We're in room 111.
111, right?
Mm-hmm.
111.
He should be here in a minute, I'm sure. Because I sent somebody for him to find him. Mm-hmm.
I guess he's sitting in a different room actually. So
I'm
maybe he's sitting in a different room. Brett is sitting in a different room.
Ah, okay. Yeah.
His presentation is already there happening, so maybe he's in some other room.
Okay. Well.
Do you have any coordinators in a different room? Can you try
Yes,
to?
yeah.
I'm so sorry for
That's
this.
what somebody was going and doing, so maybe not.
I'm so sorry for this. Yeah.
Okay. There he is. It's okay. No problem. We're all good. So you may want to go to mute, Ravi, so we can get it going
Sure.
here.
Sure.
Okay.
Thanks, Brett. Thanks.
So since I don't have a bio on you, you
Okay.
have to introduce yourself.
I'll introduce myself, no problem. Ravi is a program manager, so he's been doing product work for what we've been doing around MBSE. I have a different role within IBM. I work within our software organization, and I have an industry role that's a global industry role. I focus mainly on aerospace and automotive, but any product area that's kind of complex products I get involved in. And it's all around the engineering side that I'm involved in. My background is an aerospace engineer, but I've been doing process consulting and process design with customers for most of my career. What we're going to do today is I wanted to walk through a few areas here on talking about where AI fits, or sometimes it doesn't. We'll look a little bit about what we're doing with regards to how engineering is a little bit different than some of the other AI application areas. And then we'll get into a couple of ideas of what we've been doing with clients. There's I can't share a lot of the technical data, but I'll be able to give you the idea of what the use cases are and how successful the programs have been. So first of all, can we use AI to, really be able to automate aspects that haven't been? And we know that there are. Traditional machine learning has helped us do a number of things. We've had existing products already in the engineering world for this. And then we have a lot more capability with the LLMs. Couple of things. When you look at engineering, we have these types of characteristics here. I need to have tolerances, I have safety, security issues, and I have professional obligations as an engineer. It's professional as a PE. So what are those things and how do they fit when I get and move this into an area where I'm dealing with Gen AI, which is probabilistic, right? It's a black box. We don't necessarily understand what is going on inside of the LLM, especially if it's not on Hugging Face, it's not open source. What is it really been trained on? And of course, we know that we have some things with regards to hallucinations of the BS element of these AI systems. And one of the things that's interesting is we've gone into this in more detail, trying to get to root cause on some of the hallucinations that we're seeing. They're not necessarily just in the algorithm and in the training that happened. We are seeing errors in the actual chipsets that are causing problems. So these chips are being used in a way on AI training that they were never designed for. Okay, there are edge cases and there are corner cases of how these chips are being run 24 hours a day at such high speeds at doing very different kinds of things than they necessarily were thought they were going to be trained on in the first place. And if one register doesn't flip when it was supposed to flip, it causes some pretty major errors. So this is not going to be an area that we think is going to go away real soon. If you know VHDL process, it's been about the same thing for chip design for the last 30 years. And if we have to change the verification and validation process in there, it's a significant undertaking in the industry. We're seeing already in some of the programs, we're seeing some programs that are actually delayed because of just how much they are really using those edge cases in their F-35 program. You might look at and say, why isn't the hardware delivered yet? All right, it's really tough to do the validation to the element that you need to for some of these AI elements. So this has been kind of an ongoing area to look at. Now, one thing we've noticed is that there's certainly, and this is from Harvard Business School, there certainly are tasks that you think, I know I can use AI for, and there's another one that's really similar, but it doesn't work, right? It's because there are this strange boundary here where AI has some characteristics that work fine, but are sometimes more difficult or less difficult when you look at it from a human perception perspective. So this is something we're having to, constantly test the boundaries on. We're having to constantly look through and understand what is possible. You get a new, a new open source model like DeepSeek. You want to go out there and understand, what does it do? How is it working? Does it fit in any of these areas? Does it help us? And really look at and understand how they are changing. So when we talk with our clients, we are trying to build everything that we have within our portfolio such that people can swap in and out their own LLMs. All right, you get anything off a Hugging Face, you should be able to plug it into our model. You can have LLMs, you can have small language models, purpose-built ones, whatever you need. And I think it also helps not only to keep probing at that, but to think about what you're trying to do. If you do have more of an explorer mindset, it does seem to help. All right, we're out there to find some things. We realize there's some risks associated with it, and we might not even understand what some of those risks are at this particular point in time. But it's still worthwhile to look out there and go, what can we be doing? So this is something we do internally. We can constantly playing with the system. We're constantly going through and doing that. We encourage our clients to be doing the same thing. And there are lots of opportunity. We see a lot of areas, both from an engineering area that directly relate into the IT areas from an automation perspective. We have features that cut across these different areas that really, when we look at them, we're like, how can we, look at where those AI agents or features are going to fit into this model? And then finally, I look at, even how it applies into the overall enterprise. There was a good presentation just a minute ago on some of the AI agents next door and how they had run them. We've done that with our HR system within IBM, for instance. So it's completely automated. In fact, if you're a first line or a second line manager, you basically don't have access to an HR person anymore. You have a bot. And the bot has many different agents underneath it that do specific tasks for it that are more advanced. But you have a standard HR bot. As an individual, you also have that access as well. And what's interesting is that this is not seen as a negative within an organization. The score for our HR team has gone up about 30 points in satisfaction, right? That may not say much about the human interaction we had, but it certainly does mean that the bot interaction has been very good. And that's been one we see across the industry. HR has been just ripe for automation in this area. So we've been doing engineering AI for a while. We had our own requirements quality assistant that was out in 2018. And this product was trained on the Encosi guidebook. Went through this in gory detail. It gives you confidence factor on the different requirements that are written. Are they written well or are they not written well, and why? What are the different areas of the Encosi guidebook that did not, that does not make it? So the good thing is we see Gen AI as being much better, frankly, than this. There's some caveats to it, but really the whole LLM approach is definitely going to give us a much better interaction. We already have that. But there's also areas outside of just the requirements that we recognize. So if I go along the entire V, there is opportunity. And we're focusing right now mostly on left. But there are areas where, certainly from code assist to some of the validation and verification, we have some clients that are really wanting to look at, they get most of their designs from an OEM that is in a different geography, and they've got to take a look and they go, we're finding things we should be testing for that we didn't. And they want to know from the code, can I say, what other areas in the testing should I do? So they're trying to do a better job of testing stuff that's just given to them. They don't necessarily have well-written requirements. They don't necessarily have well-written test cases. They have, here's what the code's supposed to do. Here's the performance we expect. Do it. And they're finding it in that, as you might imagine. So we are doing other areas, but these are typically the ones that most of our clients have been focusing us on. They are tough problems, and they're perfectly aligned to an LLM approach. So, looking for requirements, quality, systems engineering, model development. This one's a little harder, gotta say. We're doing a lot of work with here, and I'll get into some details on this piece in a little bit as well. So we also, and by the way, I think those areas kind of fit when you looked at what Encosi was doing with regards to requirements work group. So they had a bunch of ideas of what AI could be used for. It's pretty consistent with what we've seen from our clients. They include many things that have multiple tasks in them. So it's interesting though, when you look at it by organization, they do these things differently. So that variation, how organizations do this, also means that we likely need to build that flexibility into the AI models. So it's not straightforward to just say, I'm going to identify or decompose requirements. People have different ways of decomposing requirements. You have different methodologies for it. And even writing good quality is not necessarily just the Encosi standard. All right, there are agile methods and other things for writing good requirements. All right, we want to be able to support those as well. So we've gone through, you look at this and you got to go, I got to build in lots of flexibility because of the way the organizations actually go after these items. One thing is, it's kind of the bot is kind of the front end, the Q&A kind of bot. How can I do stuff? right? That's kind of the entry point, and that's pretty mature. This is pretty straightforward. There's a good one from MathWorks out there that has a bot that helps you build a model, okay? And it does it quite well. But what it doesn't do is it doesn't reason, all right? It doesn't understand what a plant model is. It just understands what a Simulink model is, and it helps you build a Simulink model that does certain things. But if you ask it, hey, show me a model that, does a pump that goes 50 feet up the hill with over 200 gallons per minute up there with such and such a loss. Can you give me a Simulink model that does that? It just throws up at you, right? It doesn't understand what you're trying to do, but it'll help you build a model. So that is pretty good out there. We do see, I think another area I'll just highlight, and I'll just do a couple of these, is duplicate and conflicting. This has been pretty interesting. We do have pretty good input from that and pretty good results from this. What's been interesting is when we look at missing and correctness of traceability and duplicate, we do find some LLMs do better on one than on the other. And so trying to get somebody to give us one LLM that's going to do all three has been a little bit challenging. And we keep working with those to understand what we can do from a RAG input, prompt engineering on how to make them better at that. I think if there's anything else on here. I'll talk a little bit more about reverse engineering because that's been an ongoing customer request. A couple of examples. So one is certainly just a requirements demonstrator. So what does these set of requirements do? What does it really mean? What is the system supposed to do? All right, so just being able to query a large set of requirements and being able to understand from a prompt perspective, just, hey, I'm your intelligent assistant. Let me help you get your arms around what this whole, in this case, it's a drone, what this drone thing is supposed to be able to do. Okay. We have another one. This is one of the use cases from the Encosi one. This is from a customer in Germany, as you might be able to tell. And so just looking for similarities. So this works very well. This is one's going in production with a client. Just being able to go through, we're definitely leveraging vector databases in this case because it gives us a lot more speed. So when you look at performance on any of these AI systems, you have to consider cost as well as speed. Am I going to do this really quickly? And can I do this for a reasonable cost? We've had some customers who were going down a path with this using like ChatGPT and other sources out there, and they're finding the cost associated with running one of these was way more than the return. So you've got to look at this and go, especially if you're going to try and put something, that has your own proprietary information. First of all, I don't want that in the cloud. Secondly, if I can put it on site, it's got to still be cost effective, right? So cost effectivity is really important. I think what DeepSync did was it made a lot of people realize that even better, that it's possible. We'd always built purpose-built models of our own that are all in Hugging Face. They're all open source around Granite models. They're pretty effective, pretty small compared to anything of the larger big LLMs that are out there. This one was interesting. This just gives you a different process view. So here, same customer in Germany, they have a lot of test cases and test plans that are coming through that are in English. The person running the testing organization is typically somebody who is not an engineer. They're a test person, they're a test engineer, they're a technician. And what they're doing is they don't read English very well. So their existing process was kind of cumbersome. And so all we were doing is basically showing an integration of using the LLM for language translation, but automating it into the tool so it automatically shows up in there in the proper language for that tester, right? Pretty simple use case, but very useful for this particular client. They said the standard process for these technicians before, where they were copying stuff out of the system, putting it into Google Translate and reading it from there. Is this better than that? Yes, definitely. It might seem trivial at first, but they felt that this had a big impact on not just productivity, but also that the results were much more accurate. Okay? Because people weren't necessarily missing a character or two when you were doing copy and paste, much less Google Translate not being exactly the best. So this is an interesting one. So I talked a little bit about this. I mentioned this before. Reverse engineering is one that we have a lot of clients interested in. And there's a couple of ways to look through this on what the requirements in this code is actually implementing. So we have some customers that are saying, we keep adding new features to our code, but we haven't updated the requirements. Right? Everybody done that? I mean, I think that's pretty standard out there. Or I've done clone and own. Right? So I have something that's bifurcated from the original design. And so I want to go back and I want to document this now. Or it might be a system that, you know, hey, it was, you know, I don't know, a control system for an automobile is just associated with the firing of the pistons and, you know, how quickly we do it. That's something from Bosch from 25 years ago, and it just still works. But what the hell are the requirements associated with it? What is it really doing? All right. So how do I get that kind of work? And we can do that building it into a model, and then also understanding, you know, what in the model then are those requirements associated with this. So we're usually doing this in a multi-step process. I can't show the actual information here from the client. This has gone outside of the proof of concept and going into a limited production with the client. I will say that this client had a lot of good models and had a lot of code associated with it that allowed us to really kind of get enough data that we could train the system on it effectively. I had another client that couldn't give me code, and what he had was, you know, just test cases and a compound requirements test case document, and we just couldn't do much with it. Right? It just wasn't adequate. And the code itself, they couldn't use it because it's literally on an embedded chip that goes in a car, and there is no way to take the application code off and run it separately. It's that thing, and we don't necessarily know what it is. So I couldn't even take some C code off of there and run it and try and understand what it did. So we've had some places, depending on the data that you have, that it's going to fail, but you do need a fair amount. And we all know the public information for code models around engineering isn't a lot. All right, so it's not enough to train them on. We see in almost every case, we're going to have to do a fair amount of taking the customer's information, bringing it into the system, and doing the training. Another one. This one's pretty straightforward. I got a big model. What the heck does it do? What's this thing for? Give me some understanding of what it is. All right, everybody complains, I've got this big system model, and yet nobody can understand it except the guy who wrote it. All right, so being able to walk through, here's what it's doing, here's what this sequence diagram looks like, here's what is happening at each step. That's useful. I thought there was one more slide. So I'm going to mention one more, because I know we had another version of this, Ravi, that did have a final slide. So a couple of things that we're working on that I wanted to mention in the model-based area. One is guidance for the engineers on how to use the tool, but also, you know, how to automate specific steps in your process of going through the RFLP process, for instance. Okay, I know, it's interesting. I know we're not supposed to talk SysML in here, but with V2, there are some interesting ways they were really trying to put progression of RFLP through the process, and there's things that really fit well for AI automation. All right, so those are areas we're really focused on. In fact, automatically, when you've gotten enough definition of your functional requirements, that you might start already iterating on the next level without even understanding that you did, because you're just going through your process. You think you're still talking logical, but you're already getting into some of the physical characteristics of the system. We should know enough to automatically bring it down to the next level in the next diagram, right? That should be things the tool should do. So we're looking at things like that that are pretty interesting. Some of the other ones that we've had, Certainly, when I'm doing modeling, there are multiple different processes that we need to be able to support because everybody is doing this slightly differently. And we may have a goal of having a DDS architecture layer for the logical area that gives me a level of abstraction between the hardware, OS, middleware, and application. I want to understand what that middle layer is, and I want to be able to help them do that to specific standards. It could be FACE in aerospace, it would be AUTOSAR in the automotive world. That gives me a language that allows me to really work with a multidiscipline approach. So this is in production today in both aerospace and in automotive, where we are taking a logical architecture out of a SysML model, and we are converting that to UML. We've been doing that for 20 plus years, but we're also now doing it down into the electrical and networking areas, so the EE areas. And it did take more effort on the initial design of the system architecture. The typical system architecture that just had the functional layer without having some of that logical architecture or what those abstraction layers are going to look like and how you interact with the middleware, that was not enough information. And we had to know the semantics of what I'm going to move to electrical is different than what I move to the software. A port's not a port in software versus electrical, for instance. So just understanding those things. It's the same model, but it's not the same data that comes across for those different disciplines. So that's been a fun one. And the first benchmarks we did with client on, it was like a ADAS program inside of automotive. And it was about 3,500 hours of savings that they weren't remapping requirements into the electrical and networking models, right? So it was all manual steps. And there was another 2,000 hours that they would normally be doing that on the software side as well. So huge amount of savings. And when I look across the industry, see a lot of the startups, they don't work that way. They have an integrate, they reuse that data down into those domains because they have one engineer on top of this function that follows it through the life cycle. Everybody else in this classical area for auto and aero, you throw it over the fence to the next guy. There isn't somebody who owns the whole life cycle. So there's a big process change. And that's the same thing that we see in the Chinese automotive market. It's very much more integrated, and they've already transformed out of that throwing it over the wall, model of who owns what. They only own parts of it. So if you own, lane keeping assistance for a car or an autopilot approach algorithm for an aircraft, we want someone to own it through the implementation of that so they understand the whole process. Because I can guarantee you most of the engineers in the traditional world do not understand. If you're a software guy, you have no idea what those implementation people are doing, how they're figuring out the network design, how they're figuring out that. If you don't walk through it, very difficult. It makes for much better planning. So with that, I'm going to ask for any Q&A, any questions?
Yeah, so we've got a few minutes. Lunch doesn't start till 11:30. One of the good things about being the last person up, you get 5 extra minutes.
But it is lunch.
Questions?
Brett, can you accept my sharing screen? Brett, can you accept my presentation? I mean, I will be sharing that last slide that has not been updated. Yeah. Can you accept that?
I cannot. That's all right,
Okay.
Ravi. We're good.
Okay, fine.
Was that your colleague or somebody else?
It was Mike. Okay. He had found this slide that was missing. That's all right. I explained it, I think, to the extent I could.
No question on the presentation by you, Barnwal, right? Is a lot of this bleed over to like the IBM federal work, or you guys independent of federal?
Yeah, software, our organization cuts across all of our clients. So we don't have anything specific for federal versus not. Obviously we have a client coverage that's specific, but.
Are you involved on the AI documentation, both capture at all?
not specifically with a DoD or a federal focus, but we have done a lot of work on RFP analysis and bringing that automatically into basically into doors, right? We're IBM. So we're bringing that into doors or doors next. That's been a common request, and that's actually pretty straightforward to bring those in and map them out.
2 days ago, I saw
Somebody probably did the work. I had one, the first one I saw was in Singapore, so I know we've been doing them.
Questions?
It's a great mic.
That's the one.
Some of the stuff you're talking about at the end, where like, it seems like you're kind of, recommending that it's better for engineers to kind of own a small, a vertical slice instead of a horizontal slice. Is that kind of what you're?
No, so you still need to have strong horizontal and vertical. What I was showing was that there are some of these smaller companies and some of the Chinese where, and actually that's that in some of the tier ones, where somebody who owns a function or a feature, and usually a software driven feature, right? And we're all trying to move to software driven vehicles or software defined vehicles, excuse me, that the owner of that owns the entire life cycle of that particular feature. And therefore they're walking it through the process. And so you basically have a chief engineer of the particular process of that particular feature through the whole life cycle. And it just has a very different viewpoint then of why aren't I reusing what the last group did? And it makes them focus on that.
Sure, I guess, does that kind of go along with like decoupling, like monolithic architecture?
Correct.
Oriented, that it's easier to kind of take that slice.
Absolutely. And so it is about software-defined vehicle. It is about having full portability of the application software, right? And I can't say this enough. I still have to describe a lot to the mechanical engineers that run engineering at very large companies, what that means and how you extract the application software from all the other stuff underneath it, right? And they have a hard time with that. And when there are studies that are out there that show that software-defined vehicle, that is still probably one of the #1 hangups for companies that are late to market going to SDV. Yeah.
Okay, well, thank you so much. Let's just thank the speaker.
Thanks.
Okay, we're gonna take a 1 hour lunch break. So everybody online, you will go to another session anyway. So thank you so much for hanging in there. I know we've had issues and trying to keep cameras lined up and all kinds of other things, but we will continue to adjust as we can as quickly as possible. So thank you so much.